Hello, in this video we are going to find the Leibniz derivative formula for a specific problem. The question is, how can we calculate the following expression? 1. We have a derivative of an integral from 0 to x of a function f(x,y). To try to solve it, we recall two results from calculus. First, the fundamental theorem of calculus, and second, the Leibniz rule. The fundamental theorem states that if we define a function t as the integral from 0 to u of a function g that is independent of u, if we differentiate t with respect to u, we simply obtain the function g evaluated at u. But we cannot use this result in 1, since the function f depends on x, which is the upper limit. On the other hand, Leibniz rule allows us to move the derivative inside the integral. When the variable of integration b is independent of the variable of differentiation u. But once again, in expression 1, this is not satisfied because the variable of integration y depends on the variable of differentiation a. In short, we cannot apply either the fundamental theorem of calculus or the Leibniz rule. Therefore, we cannot solve 1 directly. We need a trick. Let's consider the function h defined as the integral from 0 to x of f t y, where we will set t equals x. The key point is that if we differentiate h with respect to x and then evaluate it at t equals x, we recover the expression 1 on the right hand side. Therefore, now we only need to differentiate h with respect to x and then set t equals x. Let's differentiate h and we obtain this expression. Now we compute each term on the right hand side. Dh to dx can be computed using the fundamental theorem, because this time f is explicitly independent of x. Moreover, dx to dx is simply equal to 1, and th to dt can be computed using Leibniz rule, since the variable of integration y is independent of t the variable of differentiation. Next, dt to dx remains as it is for now. Dh to dt is equal to this integral. Putting everything together, we obtain this. And finally, we set t equals x, and we obtain the Leibniz formula where we were looking for. To check this result, let's consider the following example. We chose this example so that we can solve it both using the formula and directly. First, we solve it using Leibniz formula. We identify the function f as y sine x. We evaluate each term, and we obtain the following result: x sine x plus x squared cosine x. And to verify this answer, now we can solve it directly. We first solve the integral using integration by part, and then we differentiate with respect to x and obtain the same result. We see that both methods give the same results. And that's all. Thank you for watching.